Hello, I'm Andy Peel from the CCDC. In this video we will see how to use the powder diffraction pattern simulator in Mercury. To begin, open Mercury. The powder pattern simulator can be accessed from the button in the Display Options toolbar or from the Calculate menu from the top of the interface. The powder pattern can be calculated from CSD entries or from your own experimental SIF files, which you can open from the File menu by going to File and then Open, or by dragging and dropping a file into the visualizer area. In this demonstration, we will use CSD entry FUYWAX, which can be selected by typing the ref code into the Structure Navigator search bar. Clicking on the powder button in the display options will launch the powder diffraction feature, showing the calculated pattern for the structure currently selected. You can see this information in the drop-down menu at the top of the window. If you have multiple structures selected, you will be able to switch between them using this drop-down menu. Here we only have one structure selected. Underneath the 2θ axis, on the left-hand side, we find the X-ray wavelength used in the simulation. In the middle, we find the current cursor position in terms of 2θ and intensity, and on the right, we find the HKL index for the peak closest to the cursor. Notice that there are tick marks underneath the 2θ axis at the position of the peak maxima. You can left-click and drag using a mouse to zoom in on a particular region of the pattern like so. A scroll bar will appear underneath so that you can move to different regions of the plot without zooming out. However, there is a reset zoom button that will return you to the unmagnified plot. Towards the top left of the window, there is a Customize button. Clicking on this brings up the powder pattern settings. In the Pattern tab, you can find some of the underlying variables used in the simulation, such as wavelength, which can be adjusted to match your typical experimental setup. A second wavelength can be added if desired. The default is copper K-alpha 1 with the option to add K-alpha 2. Additionally, there are parameters to alter the smoothness of the traces and the 2θ range of the x-axis. You can choose whether or not to include hydrogen atoms in the simulation. As you can see here, if we exclude the hydrogen atoms from the simulation, by unticking the box and clicking Apply, the pattern changes noticeably, as might be expected for a structure with light atoms only. The effect of divergent slit type can also be simulated by selecting Fixed or Variable Slit. Lastly, you can alter the peak shape by specifying the full width half-height maximum. We will click Default to reset the options. In the Display tab, you can alter the colour for the traces and additionally choose whether to display ticks for systematic absences on the 2θ axis. In the Preferred Orientation tab, you can correct the pattern for preferred orientation if you expect the crystals to have a habit with high propensity to align. A suggestion for such a direction based on BFDH morphology is given in the Preferred Orientation section. The intensity of reflections with orientations close to the specified HKL values are increased if the March delays parameter is less than 1, or decreased if the parameter is more than 1. Returning to the main window, clicking on the Save button will bring up the Save dialog and allow you to save the simulation in a number of commonly used file formats. Similarly, the Save Image button will bring up a drop-down menu of the image file formats. Selecting one will allow you to save the image. We hope that you've enjoyed this demonstration of the powder diffraction pattern simulation feature in Mercury. Thank you for watching, and don't forget to subscribe to our YouTube channel.